Hi everybody and welcome to our YouTube live today. My name's Anya and I'm going to be taking you through for the next 2 hours or so a lot of the main topics on the Leaving Cert Paper 1 higher level. And I suppose, look, the first thing to start off with is we were never going to get through everything in one revision class, but this is just a start. I've tried to select some of the main areas that I think would be important for students to focus on, but we will, of course, have further revision sessions over the next couple of months. And I suppose when we get further details on some of the other arrangements and adjustments that may be happening, we'll be able to focus in a little bit further as well later on in the year. So to start off with today, I thought it might be useful to look at the adjustments for the 2021 papers. So I suppose what's important to note is that up until this year, students would have been required to do all questions on paper 1 and paper 2 of the Leaving Cert. However, this year, what we are aware of is that there has been some adjustments made and to many of your subjects, and there's a really comprehensive document online where you can actually go and see all of the adjustments for the different subjects across the Leaving Cert. So I've taken a quick screenshot from that document and it kind of talks you through exactly what the changes are for our maths higher level paper. Now, again, this may change, we don't know, but for the moment, this is the kind of up-to-date information. So what we're being told is that for section A of both paper 1 and paper 2, there are going to be 6 questions on the paper, and these are worth 30 marks each. And what we need to be aware of then for, again, the 2021 paper, you are going to be expected to do 5 of those questions out of the possible 6. So that's for your section A. And we've also been told that it's similar in format to previous years. So again, what we're aware of is that when you're doing your revision, when you're practicing your exam questions, the section A questions are going to be very much the same as what you're used to seeing from previous years. If we go to section B, however, there is a slight change. So up until this year, we would never have been able to actually even say exactly how many marks we're going to be going for each of the section B questions. However, this year we are being told that there are going to be 4 questions and they're all going to be 50 marks each, and you will have to do 3 of them. So again, making up your 150 marks. Up until this year, I would have always had to tell students that we won't actually know exactly how many marks are going for our section B questions, and they could vary in their length and obviously the amount of marks going for them. So because we're being told that each of our section B questions are worth 50 marks, we're also being told that the amount of material presented in each question will be reduced somewhat. So look, that doesn't really give us that much extra information, but what it is telling us is that we will probably not be expected to maybe have questions with as much crossover as other years. Now, again, when we're revising, it doesn't really change anything, but it's just to be aware that maybe when you're looking at some 80 mark or 75 mark questions, let's say from paper 2, from section B, I should say, it's going to look a little bit different in this year's paper. And I suppose in a way, hopefully they might be a little bit more straightforward and again, not have as many crossover in different topics within our curriculum. As I said, this may change further as the year goes on. We just don't know yet, but that is our current understanding of what our 2021 paper is going to look like. It's still worth the same amount of marks, obviously, 300 marks for paper 1 and 300 marks for paper 2. So moving on, what we're going to look at next is we're going to have a look at just some kind of exam tips that may help you as you're going through. And again, just I suppose with everything, a lot of these tips I'm sure you've heard before. It's just, I suppose, to highlight them and to ensure that we're kind of keeping them in the back of our minds when we're doing our own revision for mock exams and for assessments that we have coming up. So number 1 is very obvious, but I'm going to say it anyway, revise the basics. And what I mean by that is if you know that, factorizing is something that you've always struggled with, or rearranging formulae, or some basic coordinate geometry things. Like if that's something that sitting here today, that's still a little bit of an issue, and each time you do it you say, oh, I'm never very good at that, you really need to try and figure those things out now. And, you know, talk to your maths teachers, talk to maybe other people in your family who've done maths before. Like, get the help that you need with the basics, because really, no matter if you're doing higher level, ordinary level, if you're doing your junior cycle exams or your Leaving Cert exams, the basics are the ones that are going to help you start your questions. They're going to help you get attempt marks. They're going to help you get follow through marks. And I suppose on our website, examrevision.ie, we have videos from, you know, the junior cert that I have uploaded into our Leaving Cert folders. And the reason I've done this is because the basics are so important. So if you are someone who has struggled with, let's say, factorising, you can go into the algebra folders. That's actually our free topic on our website, and you'll be able to see basics of factorising done out for you. So it's just, again, they're the things that are going to help you get across the line, whether it's to start a question or potentially to finish a question. That, you know, you don't want to be going into the exam worrying about something like that throwing you off. The second one is to make sure you read your questions carefully. So again, as a Leaving Cert higher level student in particular, you need to be engaging with the question. And before you start it, you should have a really good idea of, you know, where you're going. It doesn't mean you need to know every single step. There's plenty of Leaving Cert high level questions that I start that I'm thinking, I'm not really sure exactly how this is going to finish, but we need to have an idea in our head. Am I solving an equation? Am I factorising it? Am I trying to evaluate something? Am I trying to show something? Do I already have the answer and I'm just trying to prove that this is the answer I'm going to get at the end, etc., etc. So again, when you're engaging with your exam papers, do really concentrate on what keywords are being asked in the questions. Next one, again, very obvious, but remember the importance of attempt marks and follow through marks. So attempt marks are obviously major in the junior cycle and the Leaving Certificate maths exam. And I think it's brilliant because it's showing, again, when you engage with your mark schemes, when you're doing your revision, you might be a little bit disheartened with the question. You think, oh God, I really don't know what to do on that question, but I'm going to try this. And when you look at your mark scheme, which you all should really be doing, you should be practicing exam questions and looking at the mark schemes afterwards. You will hopefully be reassured that actually, yeah, I only really got a third of the question, but I have half of the marks or 3/4 of the marks. And that's because attempt marks are so important. And the reason why we place such a value on attempt marks is because you're showing an understanding and a comprehension of the topic. And that's what we want to promote, and that's what we want to see in the Leaving Cert curriculum. That while a question might be very challenging and there might be a mix of topics, that you're able to engage with it and know this is a step in the right direction. A few other just little things before we get into paper one then. We have 300 marks per paper and you have your 2.5 hours to complete each of those papers. Now, time limits. Up until this year, it was more difficult to give time limits because for Part B or for Section B, again, we were never sure of exactly how many marks were going per question because it did vary. This year, I suppose we can be a little bit more exact, but again, what I have underlined here, this is the upper time limit per question. So this is literally if you had perfect 2.5 hours and you didn't spend any time reading the exam beforehand, or you didn't spend any time going back over it, which I wouldn't necessarily recommend, but I suppose as a really easy mathematical way of doing it, you can kind of divide the marks in two to figure out how many minutes you can spend on it. But again, that is very much the upper time limit. So, you know, we're saying 15 minutes in Section A, 25 minutes in Section B. But again, what you need to think about is this year, for the first time, you are going to have an extra question in Section A and an extra question in Section B. Now, depending on how you get on with your teachers, and again, different teachers are going to have different approaches to this. Some of your teachers may have already mentioned to you that you're leaving out 1 or 2 topics. Some of your teachers may have said, no, we're doing absolutely everything. And again, it's going to vary, and each teacher, each class is different. There's no right or wrong answer for that. But let's say, for example, you do manage to get the entire curriculum complete. You might want to try and do all questions on the paper. Now, I wouldn't necessarily recommend that because you want to focus on the questions that are going to get you the most amount of marks, and you want to obviously work with them and get the most amount of marks that you possibly can. However, if you're looking at a paper and you're thinking, you know, I'm really unsure of two of those last questions, so I don't really know which one is the better one for me to do. You may end up deciding I'm going to try and do both of them and get as many attempt marks as I can as possible, and then hopefully both will be graded, of course, and hopefully one of them I will get slightly more than the other question. So if that's the case, you do also need to consider that those times that I've given you would not obviously get you across the line. So it's going to be different for every student. So as I said, that's the upper time. You can kind of, again, over the next few months, work on those and decide if you're going to have a particular strategy, and if you do hope to maybe do all of, let's say, section A questions, the 6 of them, you will have to obviously reduce your timing on those questions as well. Okay, the next thing to go on to is to look at our topic breakdown, and then we're going to start getting into specifically paper 1 for the rest of today's YouTube live. Just a quick reminder as well, if anyone does have any questions as we're going along, whether it's about the breakdown of the paper or more specific paper 1 questions, we're going to be taking all our questions through our Instagram page today. So if you do have any questions, if you go onto our Instagram, which is, I'll just go back, actually, it's on the last slide. It's at examrevision.ie. If you go onto that page, we have a question box up, so you can pop any questions you have in there, and I'll make sure to try and answer them as we're going along. And if I don't get to answer them today or during the revision class, I will make sure to put up answers on our story later on today. So between this class and through our Instagram page, I will try and answer any questions that we have. So going on then, looking at the topics that we have for the Leaving Cert. These are, I suppose, the broad topics that you will all know at this stage, I'm sure, that are associated with paper 1 and paper 2. I always say this, it's something that you have to be really cautious about, that while we have these broad areas that are associated with paper 1 and paper 2, there's nothing to stop them crossing over. And I think that's very important to keep in the back of your mind. So as I've said at the start of this, it is possible that some elements of the course may come up in either paper. So for example, we see sometimes area and volume and Pythagoras' theorem kind of are topics that have come up a few times on paper 1, and likewise you may have like differentiation, integration and algebra, of course, coming up on paper 2. So it's just to be aware that yes, we would encourage you to focus on these topics for the 2 papers, that you shouldn't be surprised or shocked if something from paper 2 does come up on paper 1. In particular, when you're studying for paper 1 for your Leaving Cert, I would recommend not looking at it in complete isolation, that, you should be definitely aware of topics on paper 2. And look, you're obviously revising now, you're going to be aware of them by the time your Leaving Cert does come around, but it's just to keep that in the back of your mind as well. So last thing I'm going to do then, before we actually go and look at topics in kind of particular, is show you this breakdown that I've done of the different topics that have come up on paper 1 for the last 6 years. Now, of course, these are very much like, broad titles that I've given to the questions. Algebra is obviously a massive topic on the Leaving Cert, so I've just written down algebra. You could go into that in way more detail, but I just wanted this to be more of a broad overview. And again, I suppose one of the main reasons I did this was actually to show you that you can't go into your Leaving Cert and say, oh, I'm just going to study these 3 topics and I should be okay. Like, it doesn't work like that. It's not like maybe other subjects where, you can kind of do a bit more predicting. It's very difficult to predict stuff for the Leaving Cert. Again, we can look at kind of broad ideas of things that maybe haven't come up in as full questions or as section Bs before. But after that, you kind of you do need to know a bit of everything, to be honest. So if you look here then, we're not going to go through this in detail, but anyone who does want these notes and this PowerPoint, if you just put your details into the form that we have in the comments in the description section, we will email those out to you in the coming days. So yeah, if anyone wants to do that, feel free to just put in your email address and we'll make sure to get those sent out to you in the next few days. But anyway, just as a broad overview, you can see if you look at the red topics even to start off with, this is all algebra and functions. So you can see, right, in last year's exam, it came up at least 3 times. And again, these are very much broad overview titles. Of course, algebra comes up everywhere, but you know, some of the topics from your algebra chapter. 2019, you can see like 6 or 7 times. 2018, like there's a lot of red in each of those years. So it's to show, I suppose, first of all, algebra and functions come up every single year, 3, 4, 5 times. They may only be a part of a question, but again, it's a part of a question that, you know, could be worth a substantial amount of marks. You can see, I suppose, complex numbers, the kind of purple. You can see one question has come up on that every single year. Sequences and series, you can see, has come up at least once every year, if not twice. Financial maths hasn't come up maybe as much, but when it has come up, we can see in 2017 it came up as a question 8, quite a substantial question, and it came up in 2020 and 2015. But what I would say is that's not an indication that it won't come up this year, because to be honest with you, if you look at all the other topics, they do come up nearly every year, so there would be nothing stopping financial maths from coming up in 2021. Again, you're going to have an option though. So, you know, even with my own class, I've told my students that we're going to leave financial maths till the very end. And that's just a decision, I suppose, I've made as their teacher. Doesn't necessarily mean it's like the correct one, but it's just something that we're going to leave that towards the end. And if we have time to do it, we'll do it, absolutely. But if we don't, you know, hopefully we'll be covered for every other question that could come up on paper 1. And I suppose if you look at the ones that I haven't coloured in, these are just, I suppose, some kind of more kind of smaller topics. You can see now logs would be very much considered paper 1 as well. It hasn't come up in loads of places, so I didn't colour it. But if you look at some of the other ones, length and area, the line, Pythagoras' theorem, area and volume, trapezoidal rule, etc. You can see some of those we would associate more with our paper 2, and it's just to show you that, you know, they do obviously come up on paper 1 as well. Okay, so what we're going to do now is we're going to get stuck into a few paper 1 topics. As I said at the start, we're not trying to cover absolutely everything of paper 1 today. That would literally be impossible. And I suppose I want to go into a bit of detail on some of the topics, because I don't want this to just be me reading out a revision list. I don't think that's going to be useful to anyone. But I will make sure when, if you do fill in the details, I will send you out a revision list that I have put together. And again, if you look on our website, ExamRevision.ie, I'll show you a few bits on that later on. But obviously the entire course is broken up into videos. So this is very much an overview. I'm going to be focusing in on a few kind of areas across paper 1. But it is certainly not a substitution for doing further kind of more in-depth topics. We'll see the feedback from today. If people think it was useful, we'll look at doing some kind of more like specific targeted revision sessions over the next couple of months coming up to the Leaving Cert. This is an overview, as I said, and I'm going to just pick a few key areas that I think would be useful, particularly, let's say, if we've got mocks coming up and things like that. Some of these topics you might not have done since 5th year either, so hopefully it'll be useful. So the first thing we're going to talk about today then is algebra and functions. So I've actually put this together into the one kind of area. Now, again, when you guys did this in 5th year, you may have kind of learnt them as nearly standalone topics, but they're so related to each other. And hopefully as the Leaving Cert curriculum has gone on, you've probably started making even more links with algebra and functions and patterns for that matter as well. So again, this is a revision list, a kind of a checklist that you could use to help you with your study. I would love to go through every single one of them, but we're not going to have time. So I've highlighted a few of them on this list. I've got a good few of the function stuff done, again, in a broad sense, and that we're going to discuss in the next little while. And then you can see I've picked a few things from the left-hand side from our algebra chapter as well. And hopefully even from when you guys would have done algebra and potentially functions maybe in 5th year, you probably have developed a lot of those skills more over the last couple of years as well, or over the last couple of months, because you would have been using algebra and functions in a lot of your other areas and chapters. So I think you will find that you're probably even more confident at some of this stuff compared to maybe last year when you did it in 5th year, for any of our 6th year students watching today. So what we're going to do is I'm going to take you through a couple of questions, a few kind of revision exercises and things like that. And again, keep questions coming in and I will do my best to answer them as we're going through. So we're going to start off then with a simultaneous equation question. So this is, I suppose, just the first bit of algebra that I think is really important that we all know. Simultaneous equations, you would have met in your junior cycle, and in leaving cert you look at it in a bit more detail and you look at the different variations of the of simultaneous equations. So the first one we're going to look at is substitution. So what you need to remember when we're dealing with simultaneous equations is that, generally speaking, so again back to junior cycle, we had two unknowns and we had two equations and we had to solve them to figure out where these two equations have the same x and y value. And if we think back to the very practical side of it, so hopefully back when you were in junior cycle, your teacher would have done some type of an activity with you where you might have drawn two straight lines. So you went and you had two linear equations, you graphed them, and you basically looked at where those two lines intersected each other. And you were able to find a coordinate, so an x and a y coordinate. And then you hopefully went and learnt simultaneous equations and you learnt this algebraic approach, and that you discovered that the solution to your simultaneous equation was where those two lines intersected each other. And that is simultaneous equations. So what we want to look at then for the leaving cert is we look at other examples where we might have a linear and a non-linear equation. And sometimes if you have a linear and a non-linear, there's a chance that you may, when they intersect each other, have 2 points of intersection. So you may end up getting two different answers. So for this question, this is type number 1. I'm not going to do out every single question because again, we will not have time for that, but I'm going to talk you through kind of some of the key things to remember in a question like this. So when we have a linear equation is where we just have like x and y. There's no squares or cubes or anything like that. So the second one here would be our linear equation. And then the one on the top is our non-linear equation. And the reason why that's non-linear is because it obviously has x squared and y squared. So we always start with our linear equation. And what we're going to do is we're going to take our linear equation and we're going to isolate either the x or the y. So I'm going to isolate, let's say we isolate the x. So I'm going to bring the y across. So that's going to give me -1 minus 3y. And I'm going to divide across by 2. So x is going to be equals to -1 minus 3y all over 2. So that's step 1. We isolate either the x or the y. Doesn't matter which one you pick. Just pick one of them and go with it. Step 2 is we have to go then to our non-linear equation. And we have to substitute. So again, that's why we're saying this is type 1 substitution. So wherever you see x in your non-linear equation, so the one that has the squares in it, we're going to substitute this in. Okay, so I'm going to take away the x and I'm going to put in -1 minus 3y over 2 squared plus, and then I'm going to put the x in again. So it's -1 minus 3y all over 2. Y plus 2y squared is equals to 4. So now I'm just dealing with the non-linear equation, okay, so the one on the right hand side. However, what we notice is we now only have one unknown, and the unknown is the letter y. There's no x there anymore because we've done substitution. So this should be a lot easier to work with. So we're going to start off by squaring out this double bracket here. So again, you can see we've got the squared on the shoulder. Now, again, depending what way you've learned, squaring out brackets, whether you use like the array method, the distribution method, there's loads of different ways, okay? So I'm not going to go through that today because that should be something that you're comfortable with, but we're going to square out this bracket. So just remember that that means that that bracket's going to be multiplied by itself. So again, if you want to write that out, that's going to be minus 1 minus 3y over 2, bracket minus 1 minus 3y over 2. I'm going to multiply the y here by everything inside. So that's going to give me, and I'm just going to leave the minuses in here for a minute. So that's going to be minus y minus 3y squared all over 2 plus 2y squared is equals to 4. Then I'm going to multiply out my brackets. So again, you can do like your first by your first, your first by your second. Hopefully everyone's pretty okay at that. And remember to multiply your denominators as well. Again, I'm just going to leave those minuses in there for the moment. Okay, next step then, I'm going to multiply across by 4 because I want to get rid of those fractions. Okay, so I'm going to multiply everything by 4. And again, remember that's the right and the left-hand side of your equation. The first one, they're obviously going to 4 multiplied by 1 over 4 just gives you 1. And I'll just tidy up the quadratic at the top. So that's going to give me 9y squared plus 6y plus 1. And I'm multiplying everything by 4. So that means that this is going to go in twice. You're going to have plus 2 bracket minus y minus 3y squared plus 8y squared equals to 16. So just remember that that's an important thing that sometimes students get wrong, is that they just forget to multiply the other side of your equation. So again, that's just something small to be aware of. So we get 9y squared plus 6y plus 1 minus 2y minus 6y squared plus 8y squared is equals to 16. Okay, so if we tidy up then the y squareds, so that's going to give me 11y squared plus 4y. Bring your 16 over, so that's going to give me minus 15 is equals to 0. So we're going to go and factorize that then. I suppose, again, another thing just to note at this point, this is a quadratic. So because it's a quadratic equation, you've got two options. You can factorize it and solve it, or you can use your minus b formula. Again, either method is completely fine. You will note sometimes that it can be difficult to do your factorizing method depending on the question. So your minus b formula might be easier to use. So again, completely up to you, whatever you're comfortable with. So I'm going to set this up using just my factorizing method, and I'm going to go and solve it. So I'm going to get, so you let each of these brackets equals to 0. So you're going to get y is equals to minus 15 over 11 and y is equals to 1. At this point, we're nearly there. We've got our two y values. So now I need to go and substitute that back in to get my x value. So just remember that when we have our two, either it's x or y values, you're going to substitute it back into your linear equation. That's obviously just the easiest thing to do, so that you're not kind of messing around with the quadratic. So you're going to input those back in, you're going to substitute it. I'm not going to do that out, but you should end up with an answer of x is equals to 17 over 11 and x is equals to minus 2. Okay, so again, we've got our two answers here. So if you want to put those, you could go and put those into your coordinates, and you'd end up having minus 2 and 1, and then the other one would be 17 over 11 and minus 15 over 11. Okay, so that's our first example of simultaneous equations using our substitution method. Okay, going on to example number 2 then, and what I've done, guys, is I've put all the solutions to these into this PowerPoint, so when I do send it out, you'll have all the solutions, because as I said, I'm not going to go through each of these step by step, because we just won't have time, but I just thought that was a good one to do. So the next one then is simultaneous equations, but this one is where we have 3 unknowns. Okay, so I call this kind of type 2, where we have 3 unknowns. So this is kind of like a 3D coordinate grid where you've got your x-axis, your y-axis, and your z-axis. So the first thing that you're going to remember with a question like this, and I always say it when I'm teaching this, is we want to get it back to our junior cert kind of steps, okay? Because I suppose this these examples, we've got an x, we've got a y, we've got a z. So you're kind of thinking, if I could just get rid of one of those letters, it would be back to junior cert. Nice and easy. an X and a Y, or even if it's a different letter, 2 unknowns, 2 equations, happy days. That's what we're going to try and do. So what I normally start off by doing is labeling these, let's say A, B, and C, or 1, 2, and 3. And the method to solve this type of simultaneous equations is we are going to use the elimination method that you would have used in your junior cert. And we're going to try and get rid of the same letter in 2 different combinations of your equations. So what I mean by that is you're going to take, let's say, A and B, and you're going to decide to get rid of the Z, let's say. And then you'd go and you'd pick B and C, and you get rid of the same letter. And if you've gotten rid of the same letter twice in 2 different combinations of your equations, you're then going to be left with 2 equations with 2 unknowns, and you're back to junior cert maths. So what makes this question a little bit easier is that your C only has 2 unknowns. It has an X and a Z. So that's kind of nearly like step 1 done for me. I already have an equation that only has 2 unknowns in it. So that's kind of nearly like the first bit done, makes this easier. So now I'm going to take A and B, and I'm going to say to myself, okay, let's get rid of the same letter that's missing from C, which is a Y. Okay, now even if that hadn't been in this question, you still would have done this step. So we'll choose to get rid of one of the letters. I'm just choosing to get rid of Y. So we're going to use our elimination method. So I'm just going to write these out again. And the trick, again, all the way back from your junior cert, the way that I teach this is to get rid of a letter, you're going to pick whatever letter you want to get rid of, and you need to make sure that they both have the same number in front of it, and that one is a plus and one is a minus. So when you go and do your addition, it's going to give you 0. So I have to get rid of the Y because of my C equation. So I need to make them both into 6. Hopefully we can all see 6 as the correct one to use, but I need to make one of them a minus as well. So I'm going to multiply the top line by 2, and I'm going to multiply the bottom line by minus 3. And that should give me 6 then, and minus 6 to calculate my final answer. So I'm going to go, sorry, I don't need to draw a line there. I'm going to go and multiply these out then and bring the answers down here. So that's going to give me 4x plus 6y minus 2z is equals to minus 8. And that's going to give me minus 9x minus 6y minus 6z is equals to, let me just get my calculator here. So it's going to be 14 by 3, or by minus 3. That's going to give me minus 42. Okay, now I call this next step column addition. You're just like adding the variables going down. So that's going to give you 0 straight away. Then I'm going to have minus 5x minus 8z is equals to, and that's going to give me minus 50. Okay, so that's your second equation. Okay, so you've got minus 5x minus 8z is equals to minus 50. Now the brilliant thing about this is that I now have 2 equations, so this one here and this one here, and they only have 2 unknowns. So I am back to junior cert maths now. Okay, so what we're going to do is we're going to line them up underneath each other. And we're back to junior maths. 2 unknowns, 2 equations. We're going to use your elimination method. It would make sense for me to get rid of the x first of all, because one is a plus and one is a minus. It's just the easiest one to do. So I'm going to multiply that out. I'm going to get 5x minus 15z is equals to 13 by 5 is 65. Okay, we're going to do our column addition again. So we've got minus 15 minus 8, which gives me minus 23z. And that's going to be 65 minus 50, which gives me 15. Sorry, that was minus 13. I was thinking there that should have given me a bigger number. So that should be minus 13. So that was minus 65. So it's 65 and you're 50, which gives me minus 115. and I'm going to divide that by my 23, so it's, or minus 23, so I'm dividing that in, and I'm getting that z is equals to 5. Then you're simply going to substitute that back in up there to get your x value, and you end up getting x is equals to 2. And then finally, to get your y value, you're going to have to take both of these answers, your z and your x, and you're going to substitute it back into one of your original equations that had y in it, and we end up getting that y is equals to minus 1. Okay, so that is our next example on simultaneous equations where we have 3 unknowns. Okay, so moving on, we're going to look at a few functions questions, and we're going to go back to algebra as well. So again, I'm trying to kind of connect these together. So the next little bit is just a quick overview of a few kind of important things to be aware of. So I'm assuming nearly everyone doing higher level maths at this stage is going to be comfortable with the next couple of slides, but the reason I'm going back over them is because when you go and look at them in other areas, it's really important to have some of these kind of key things learnt off. So we should all know, first of all, in linear functions, a linear function is a linear graph, which means that we have an x value to the power of 1. Okay, so it's a straight line graph. So again, we know linear graphs are straight line graphs. And I suppose one of the important things to be aware of is that in a linear function, we have our function a plus bx. So again, it has one independent variable and one dependent variable. And again, a kind of a little side note here, in a linear function, the first difference is always constant. So if we link that with our patterns chapter, which again, sequences and series, it all overlaps each other. They're not standalone topics. They're literally mixtures of each other. We know that if we have a linear pattern, an arithmetic sequence, the first difference is always constant. Moving on then to our quadratics, we should all know then a quadratic is where we have x to the power of 2. Okay, so we've got 2 on the shoulder. We know what the graphs look like. You've got your parabola. It's either going to be a positive one like this or a negative one like that. We know what it looks like. It's in the form ax squared plus bx plus c, where a is not equals to 0. And we know again in a quadratic function, or a quadratic pattern, that the second difference is always constant. So that's just, I suppose, a little recap of that chapter also. Moving on then, we've got our cubic functions. So our cubic functions are written in the form ax cubed plus bx squared plus cx plus d, where a is again not equals to 0. And your cubic function, the greatest power, is obviously going to be 3. And following on then, in a cubic function, the third difference is always constant. So you can see the relationship between all these as we're going along. And look, the graph of a cubic is going to look different depending on how many roots it has, and we'll get into that in a little while, but there are just some examples. Okay, the next one then is your exponential functions. And again, I suppose with an exponential function, you're looking at the fact that the unknown, or your variable, is going to be up on the number's shoulder. And I have just a little note here. Log functions are the inverse of exponential functions. So it's just to show you the relationship between them. We will be talking about inverse in a little while as well. And as I said, exponential functions are in this form here. A to the power of x, where x is a variable and a is a constant. So a constant is just a number. And in an exponential function, the common ratio is always constant, where each of your terms is multiplied by something to get to the next term. Okay, so that's just a little recap of some of the different types of functions that you should be aware of for your leaving certificate. I want to talk to you in a bit more detail now about kind of quadratics, and I'm going to bring in roots and factors, and you can predict where it's going. So just a really quick recap again from your junior cert. You should have done this, where again you were taught how to draw a quadratic, you would have been taught how to factorize a quadratic, you would have been taught how to solve a quadratic, and then hopefully you tied it all together with this slide here. So we've got a quadratic, I've factorized it, I've solved it, and I've got two answers. X is equals to 4 and x is equals to 6. And if we went on to GeoGebra and we went and put this formula into our graphing calculator, which I would really recommend. I'm sure you all have used this at some point with your teachers over the last few years, but I would really recommend that when you're working with functions and graphs, if you're ever kind of unsure about maybe what your answer means, just go and actually I use Desmo a good bit, or like I said, GeoGebra is another really good one. If you simply just go and type this into your Desmo's graphing calculator, you get this, and you can start making a few connections with some of the different ways we've learned to deal with quadratics over the last number of years. And I suppose, look, the biggest one that you need to know is that the solutions that you get to your graph are going to be where your graph intersects the x-axis. And you would have learned back in junior cycle, or you should have anyway, is that these are like the roots of your equation, or the solutions to your equation. And again, this is the value where it crosses your x-axis. So that's just a really important thing that you will have, of course, done this year and last year, but it's just to refresh your memories of what a root actually is. And we know then when we want to go backwards, and let's say in an exam question we're given the roots and we want to go and work out the equation, we can go backwards and we can get the factors, which we can then multiply to give us the equation. So we can see how we can actually work forwards and backwards with factors and roots and equations. And that is just a kind of an important thing to be aware of. So as I said, with the root of an equation, it's the solution and it's the value where a given function equals to 0. Okay, so then staying on the topic of quadratics, I thought another important thing to go back over that you might not have seen for a while is completing the square. Okay, so first things first, a reminder that completing the square is to do with quadratics. Okay, so I suppose when you go and do completing the square, again, generally speaking, students do it in 5th year. You kind of get to the point where you're like, why are they teaching us this? Sure, we already know how to get the answer to a quadratic, but you need to think about what that answer is. So I've just shown you that when you factorize and solve a quadratic, it's giving you the answer to where that graph crosses your x-axis. Completing the square, while it can give us those two roots, it also can give us different information. Okay, so when we're asked to complete the square, I have an example done out here for you. So for anyone who's forgotten how to do completing the square, first of all, just to let me talk you through that first. So basically what you do is, I always get my students to set it up like this. So we have, you'll do your, I'll actually do it up here. So you'll come underneath and you'll do that squared minus something squared, and then it's plus 10, right? So whatever the constant is at the end, you just write down straight away. And then what you do is you say, right, I'm going to put the x in here because that's part of your perfect square where you have your x. And then you take this and you half it. So you take the coefficient of x and you half it. So obviously half 10 is 5. And if that was a minus 10, you'd be putting minus 5 in there. But obviously it's plus 10, so you're putting plus 5 in. And then whatever number you just wrote down there, you put in here straight away. Okay? So I have it written there, the number will be half the coefficient of x, and then subtract the number in the brackets squared. So again, if you remember for completing the square, you do it like this. And then whatever the constant is plus or minus at the end. So you're setting up your x, you're taking the coefficient of x and you're putting it there, and then you're putting that number in there as well. I know it's a bit of a kind of a weird one, like, it's one of those ones when you're teaching it, it's very kind of like step by step, but actually that's not the important bit about it. It's the next bit that I think gets overlooked sometimes. Why are we doing this? And the reason why we complete the square is because it helps us to figure out another really useful part of a quadratic, and it's the turning point. So what I've done here, again, I would have done this with my own class when we did this in 5th year, is we would have learned how to complete the square, and then I would have gotten them to go on, or I would have gone on to Desmo's and I would have shown them this graph. And it might take a few minutes to notice it or a few seconds to notice it, but what you'll see is if we look to this point down here, this is the point minus 5, minus 15. And we can see when we look back up to our equation, or our completed the square quadratic here, our expression, that basically what we do is we take this number in here and we change the sign, and we take this number and we leave it exactly as it is, and that gives us the turning point of our graph. So we now have another way of understanding quadratics. We can solve a quadratic to work out where it crosses the x-axis, so that's the root, so I could have gone and done that, no problem. But then we can also work out the turning point by completing the square. And I suppose another value that you could very easily work out as well, if this was your equation, is that you can let your x equals to 0 and it will give you your y-intercept as well. So you can see that there's lots of different, I suppose, ways that we can actually understand quadratics. And I suppose just another thing just to note, if you were being asked to solve using completing the square, you just complete the square as normal, and then you obviously go and solve it. You're getting the x by itself, so you can bring the 14 over, you get plus 14, square root both sides, minus your 4. Now that answer there, probably, again, you're like, okay, grand, yeah, it's in kind of Cert form. That might be useful to us. And I'm going to show you an exam question where that was useful. But again, really that answer at the end, I could have just done using my junior cert, solving a quadratic using the minus b formula or using factorising and solving. It's this answer up here that actually is the important one. And I'm going to show you now a graph of this particular function now. So let's predict what it's going to look like. So looking at our completed the square, we can see that it's going to have a turning point at minus 4, minus 14. And again, this doesn't mean much to me in this particular format, but if you went and typed that into your calculator and pressed S to D, it will mean more to you when we look at this next graph. And I could also work out where it's going to cross the y-intercept by letting x equals to 0. So I know it has a y-intercept of 2. So if we go and look at this on our graph then, hopefully we can see that. So we can see it's got a y-intercept of that, turning point of that. And then again, that's your answers when you've actually worked them out as decimals. Okay, so again, that's just a quick recap of some really important things to do with quadratics, all in your algebra and functions chapter. And then the last thing I want to look at to do with quadratics specifically in your algebra chapter is discriminants. So it's another thing that you're very much expected to know, that the part of your minus b formula underneath your square root can really help us to figure out the nature of the roots of a quadratic. So again, when we're talking about discriminants, you need to remember that it's to do with quadratics. That's another mistake I would see sometimes, where I suppose you've got all these different things that you need to learn off by heart, and it's just important to remember that discriminants are for quadratics equations. So b squared minus 4ac, you just need to remember these 3 key facts. That when you work out b squared minus 4ac, you get an answer that's greater than 0, it means it has 2 distinct roots. So on your graph then, your quadratic is going to cut the x-axis twice, so at 2 points. If b squared minus 4ac is equals to 0, it has 1 repeated real root. So that means that it's just going to touch your x-axis once. I'm not going to be able to do that now. Yeah, something like that. And then if it's less than 0, it has no roots. So it does not intersect the x-axis at all. Okay, so again, that's just another quick thing that you need to know off by heart. Now, I'm not going to go through this entire exam question next, but it's just to show you how this has come up, all those things that I've kind of gone through in the last 10 minutes, how this came up as a section A question. So it says write the function fx equals to 2x squared minus 7x minus 10, where x is an element of or, in the form a bracket x plus h to be squared plus k. So that's them basically saying to you they want you to complete the square. Okay, so just one little side note that I didn't mention in our last point on completing the square, we always want the x squared to not have any constant in front of it. So the first thing you would need to do to answer this question is factorize out the 2. So basically, like, just get rid of the 2 and bring it out to the front before you go and complete the square. Okay, sorry, that should have a squared on it. That's the first thing. Now let's just go and complete the square on this really quickly. So I'm going to leave the 2 outside. Just forget about that for a minute. So do you remember we set it up like this? So we take the x and then we take whatever the constant is in front of x and we divide it by 2. So that's going to become minus 7 over 4. And then we take that and we put it straight in here. Okay, and that's how you're going to go and complete the square. So that's going to end up giving you an answer of, so x minus 7 over 4. And when I go and work that out with my calculator here, that's 7 over 4 And remember, it has a minus outside of it, outside the bracket. So obviously the minus inside will go to plus, but it won't change the one on the inside, or the outside, I should say. And that's going to give me an answer of minus 129 over 16. Okay, so what I've done there is that's the, I've added the two constants together, and then you just need to multiply across by 2 now. So the 2 will just come and sit outside here. So you don't go and do anything with that bracket, but it will multiply by this fraction. So it's going to become minus 129 over 8 because I've multiplied by 2. Now that's an important little step at the end. Because if you didn't multiply the second part by 2, you're going to not be able to answer the next part correctly. So it says, hence, write the minimum point of f. So because, again, this is a positive quadratic, the minimum point is obviously your turning point down here. So we know now from what we've just learned a few minutes ago that to get the turning point, we take this and we change the sign. So it's going to become 7 over 4. And we just take this as it is. So it's going to be minus 129 over 8. So the big mistake when this came up previously was that students thought it was 129 over 16 because they hadn't multiplied across by 2. The next question, explain why f must have 2 real roots. So this is where you need to remember your discriminant. So you need to say b squared minus 4ac. If it has 2 real roots, it should be greater than 0. So you can come back up here, you can say a is 2, b is minus 7, and c is minus 10. And I'm not going to do it now, but when you sub that in, you're going to get an answer that's bigger than 0. So therefore, it has 2 real roots. And then the final part of this question says, write the roots of fx equals to 0 in this form. Now, basically they want you to go and use your completing the square that you've just done, and they want you to let it equals to 0 because they want you to find the roots. They want you to solve this. So it's like the example, the second completing the square example I showed you a few minutes ago, where you were able to write your answer in Cert form. However, you could have actually gone and used your minus b formula here as well, and you'll get the right answer because you'll be able to represent it in that form as well. But basically what you could do, the quickest way to do this would be to take this, let it equals to 0, bring your minus 129 over 8 over to the other side, divide by 2, square root, bring over your minus 7 over 4. I'm not going to go and do that now. The solution is on the next slide, but that's again a follow-on of what we've been doing. Okay, so we're going to keep going, guys. Hopefully everyone is with me so far. And again, anyone who puts their details in the form down the bottom of this, I will make sure to send all your all this information onto you afterwards, so don't be worrying about like taking loads and loads of notes or anything. So the next thing I want to talk to you about is your factor theorem. This is absolutely essential for the Leaving Cert course. So basically we've already actually looked at it with quadratics, and you've done it in your junior cert. Like you would have learned all this information for your junior cert. It's just putting a bit of more of a formal slant on it. So what we're saying is, with the factor theorem, a polynomial fx has a factor x minus a if and only if f bracket a equals to 0. So basically what that's saying is, if you can substitute in something into a polynomial or into a function. So a, we're saying a could be the number 2, the number 1, the number minus 100. If you sub it in and you get the answer of 0 when you evaluate that function, that means that that is a root, which therefore can be changed into a factor. Okay, that's all it means. So again, the idea of this you would have been dealing with in your junior cycle exam. And what we're saying here is that the reason why we, I suppose, give it a bit more of a fancy title in your Leaving Cert is because it's really useful when we're dealing with cubic equations. Because we can, if we can work out the initial factor or root of your cubic, you can then use long division to work out a quadratic, which you can then solve or factorize, and you can work out factors and roots from there. So that's why the factor theorem is so useful. And again, it is something that does come up relatively frequently on the Leaving Cert course. So this is an exam question we're going to look at together then really quickly. So we're told if fx equals to x cubed minus 17x squared plus 80x minus 64, show that f of 1 equals to 0 and find another value of x for which fx equals to 0. So there, they haven't used the word root or factor, but that's basically what they're asking us to do here. So this is a root, And all they're asking you to do to start off is just prove that that gives you 0. So they're actually being quite sound in this question. They could have just said, work out the roots or the factors of this cubic, and you would be expected to know how to do that without any other hints. So if they didn't give us that massive hint that f of 1 gives us 0, you would have had to use trial and error to work out the first root, okay? But in this one, they've told us. So if you did ever have to use trial and error, basically you just guess a few numbers and you sub them in. So again, I would always say to my students, pick like -1, 1, 2, -2, whatever. So all you have to do for the first one is literally just sub in f of 1. So 1 cubed minus 17 times 1 squared plus 80 times 1 minus 64. And you will get that that's equals to 0. So therefore, it's a root. Okay. And therefore, if that's a root, so x equals to 1 is a root, we can very easily work out the factor. And the way that you do the factor is you basically bring everything back over to the left-hand side. So if you imagine originally when you have a factor, you let it equals to 0 and you solve it. So now we want to bring that back over. So the factor is going to be x minus 1. Okay, that's your factor theorem. Next, you're going to work out the other factor. So what you do is you say, okay, I have one of the factors and I know if I divide this in, it should give me the other factors, because we know division is obviously a way of going backwards to work out the other factors. So you're going to do long division. Again, this is, I suppose, one of those examples where I'm like, if you don't know the basics, you're going to struggle on this question. Like, if you know the steps here, this question is pretty easy. But what could happen is if you haven't gone over your division before, and again, I know not every student watching this might use long division as your method. Your teacher might use the box method with you. Either one, you'll get the answer. I'm just going to do it the long division method because this is the way that I normally teach it. So you look at your x out here and you say, what do I multiply x by to get x cubed? And it's x squared. So then you take that number and you're going to multiply it by both of these terms. So that's going to give me x cubed minus x squared. You're then going to change both of their signs. And we do this thing that I call column addition. So it's going to give me minus 16x squared. And I'm going to bring down my next available term plus 80x. I'm just going to put in not the right one. There we go. Okay, just so I can write on it. Okay, so that's going to give me, what am I doing here? Oh yeah, okay, so I brought down my next available term. So I'm going again, I'm looking at my x again, and I'm looking at my minus 16x squared. So what do I multiply x to get minus 16x squared? I multiply it by minus 16x. So again, I'm going to take that and multiply it by both of these guys. So that is going to give me minus 16x squared plus 16x. And then I'm going to change both of their signs. And that is going to give me, so that's going to be, what's that going to be, 64, isn't it? So that's going to be 80 minus 16. So that gives me 64x. Bring down my next available term, which is minus 64. What do I multiply x by to get minus 64x? I multiply it by, or plus 64x, I should say. So that's going to be plus 64. So that's going to give me 64x minus 64. Change both their signs and they both go to 0. Okay, so this is my quadratic now that I'm concerned with. So we take our quadratic and I want to factorize it. So it's x and x. That's going to be 8 and 8 minus and minus. So therefore the other root is x equals to 4, or x equals to 8. Okay, that's your other root. Right, we're going to move on now. I want to talk to you now about rational inequalities, or inequalities in general. So I suppose inequalities is another part of the algebra topic that you need to be aware of. I suppose a few kind of minor things just to do with inequalities. Make sure you're reading to see what x is an element of. So we're being told it's real numbers. So if you remember back to your junior cert, if you ever had to go and graph that, you're thinking about the fact that it's all numbers that will satisfy it. But I'm going to talk to you more specifically about rational inequalities. So the trick here that we need to remember if you get a rational inequality coming up on the Leaving Cert exam is we obviously want to get rid of this fraction. But the trick is you need to remember is that we multiply both sides by x plus 2 squared. And the reason why we multiply it by x plus 2 squared is obviously inverse, we want to get rid of it, so you do multiply. But because it's a fraction and we don't know whether that's a plus or a minus, when we multiply across by a minus in rational numbers, we know that we flip the inequality. So because I don't really know what that x is equals to, I can't assume that it's going to give me a positive answer. So that's why you have to multiply both sides by x plus 2. That's such an important thing to know for this question. Again, I'm not going to go through this in loads of detail, but when you multiply both sides, you're going to end up with 2x minus 3 bracket x plus 2. The reason why one of those squareds cancelled was because we had x plus 2 underneath, and we're going to multiply that double bracket, so that's going to give me x squared plus 4x plus 4. I'm going to just write down what the answer is here because I'm just conscious of time. I want to keep going. So that's the answer that we should get. X squared plus 11x plus 18. Now, the reason why the inequality flipped is because basically when you go and multiply this out, you end up having 2x squared on the left and you have 3x squared on the right. So when you bring this over, it becomes a minus, so you end up having minus x squared, which you don't want. So that's why we end up changing all the signs, and the inequality goes from being that way to being the other way around. Again, if that's something that you're kind of not sure of, I've all the videos done out of all the inequalities on our YouTube or on our website, examrevision.ie, so do have a look at that. But the last bit I want to talk to you about, so that's the rational inequalities bit here. This next bit is the quadratic inequalities bit. So there's another little step you need to remember at the end. So what you do is you actually pretend to solve this for a second. So you let it equals to 0. So we go and factorize this and solve it. So it's 9 and 2 plus and plus. So I get x equals to minus 9 and x equals to minus 2. Okay. But that's obviously not the answer because it's an inequality. So this is the really important bit you need to remember then to finish this off. So you go and you sketch where minus 2 and where minus 9 is, and you draw your quadratic. And because this quadratic is less than 0, you need to shade in the places that are less than 0. So it's all along here. So that means that you've got a sandwich inequality. And this is where your answer comes from, that it's going to be between minus 9 and minus 2. Now, just a little side note, generally speaking, you're always going to put the equals to sign underneath because that's what we had in our inequality. But just in this question, it said x cannot be equals to minus 2. So therefore, that's going to be your final answer there. So it's a sandwich. Whereas if our inequality was the other way around, if it was greater than or equals to 0, you'd be shading in here and here, which obviously it's not in this question, but if it was, you'd be saying x is less than or equals to minus 9, or x is greater than minus 2. Okay, but that would have been if it was the other way around, which it was not. Okay. All right, we'll keep going. Right, so what we're going to move on to next then is transformations of functions. This is definitely a topic that I get asked to kind of revise quite frequently. So I'm going to talk you through a few quick steps to remember transformations. So the first thing you need to think about, and I always go on about when I'm doing transformations with my students, whether the change happens inside or outside the bracket. It's not a very technical term, but it does really help when you're trying to learn these off by heart. So what I do is, instead of teaching it as, oh, this is what happens to quadratics and this is what happens to cubics and exponentials, we learn it as a general rule that will work for all transformations of functions. So in this particular first example, you can see we have fx, which is x squared. And we're being asked, what about this graph? So this is the graph in red. And what we can notice is that the graph has moved 2 up. Now, the reason why it's moved 2 up is I'm saying it's outside the bracket. That will make more sense in a second. So it's outside the bracket, which means it's always going to change your y values. And it does exactly what we think it's going to do. So it's going to plus 2 to all your y values, and that's exactly what's after happening. Each of your y values has been shifted up by 2. It's been moved up by 2. And similarly, if this was minus 2, so if you had fx minus 2, all that would have happened was it would have come down, be shifted down by 2, and your quadratic would have been like that. Okay, so that's the first rule. So that's your first rule for vertical transformations. When the change happens outside the bracket, all the y values are changed. So again, if you have a plus or a minus, basically it just moves up or down your y-axis. Okay. The next one then is horizontal transformations. So that's when the change happens inside the bracket. So again, I say to my students, right, it's inside the bracket. That means it's going to change not your y values, it's going to change your x values, but it's going to do the opposite of what you think it's going to do. So when that says plus 2, it actually means minus 2. And think about where your x-axis is. It's obviously the horizontal axis. So that's why this is a horizontal transformation. So we can see in this example, it actually moved 2 to the left, even though instinctively we would have thought it would move 2 to the right. So again, to recap what we've learned so far, if it's outside the bracket, it changes the y values and it goes up and down as you would expect. And if it's inside the bracket, it changes the x values and it does the opposite. So if you think it's going to be plus, it actually goes minus, and vice versa. And there's just a little summary of that there. Moving on then, if we have a number that's outside the bracket again, but this time it's stuck onto the fx. So you need to remember in algebra, when stuff are stuck onto each other, it means that they're being multiplied by each other. So this is saying 2 multiplied by fx. So again, as usual, you say it's outside the bracket, so it will change the y values still, and it does exactly what you expect it to do, which means you multiply them all by 2. So this red line here was the original graph. So basically, if you went and took a point on this original graph, that point there, that's the point 1, 1. So now what we're saying is we need to multiply all our y values by 2. So that's going to become 1, 2. And if you look here at your blue graph, that's exactly what happened. It went up to 2 on my axis. And similarly here, this was the point 2, 4. Multiply your y value by 2, it's gone up to 2, 8. Okay, so that's your stretching of your graph basically. So you can see here when it's outside the bracket, it changes your y values, and it means all your y values are being multiplied by that number. So it's going to stretch it up. When it's inside the bracket though, it's going to change your x values and it's going to do the opposite. Okay, and then the last thing with transformations that you need to be aware of, and it's basically the same rule, but it's just to show you, it's outside the bracket. So again, you say it's going to change your y values. And if you imagine it's going to change all your y values sign. They're going to go to minus or plus depending on what they were. So if you think of your original graph here on the right hand side, if you took this point here on the y-axis, it's just going to be flipped down there. And if you took this point here, it's being flipped down there. Okay, so basically what happens is when the minus is outside, it's changing your y values, which means it's a reflection in your x-axis. Okay, moving on then to the other one then, when the change is inside the bracket, it's going to be the change to the x values, which means it's going to end up being a reflection in your y-axis. Because if you can imagine your blue line was your original line, that was originally 1, it's being flipped around to -1. That was originally whatever, it's being flipped the other way around. So it's just being a reflection in your y-axis. It's coming across, so like that one is going across to there, etc, etc. Okay, and all those are summarised, and that's just a quick little recap activity. You can see this +1. You've got your original black line is being moved up by 1. Here we can see it's 2x. That means it's actually being like squished in because your x values are being divided by 2. This one, you're thinking about it's inside the brackets, so it's going to change your x values and it's going to actually go to the right instead of the left. So you can see it's been moved 1 to the right. And then this one, the 2 is on the outside, which means it's going to change your y values and everything's going to be multiplied by 2 on the y. So it's going to be stretched down there by multiplying by 2. Okay, now we're going to move on to the 3 different types of or versions of functions, injective, surjective and bijective. So a very, very quick recap of this. First of all, let me just speak to you about a normal function. So this first example here is not a function. The reason why this is not a function is because we can see that there's two answers or two outputs coming out of our first input, and that is impossible. So our definition of a function is that it should only ever have one output coming from a particular input. So this is not a function. This next example would be, it's just a normal function. Okay, and the reason why this is a function is you can see each of our a values have been used, which it needs to happen, and they've all only been used once. And you can see that they've just gone to a few random outputs. It's perfectly fine not to have all of these guys filled up. But what we will notice is that while you can't have two arrows coming out of the same input, it is perfectly fine for two inputs to go out into the same output. Okay. Other terms that you will need to be familiar with in your functions chapter is your domain and your range. So this would be your domain, and this would be your range, okay? So your range are all the values that you actually use, and then this one included down here, this would be your codomain, so all of your possible outputs. Now we're getting into injective, surjective, and bijective. So it's important to note that not all functions have to fit in injective, surjective, and bijective. So the definition of injective is that each input goes to its own unique output. And each output, is only going to be used once. Okay, that's the important bit. Okay, so each of your outputs will only have one unique input going into it. So this would be an example here, because what we can see is it's 1-to-1. So all of your outputs, or your inputs, I should say, are going to one distinct answer or output. It's okay that this one down the bottom isn't used. That would be what we call an injective function. If we look at the next one then, this would be an example of a surjective function. The reason why this is surjective is because all of your outputs are being used, okay? So every single one of your codomain is being utilized. It's okay that some of them are being used more than once, but they all have to be used. So this one would not be surjective because this one here wasn't used. And then finally, as you can probably imagine, the last one is bijective. And bijective is a combination of being surjective and injective. So it means that every single one of your codomain is used, but it is only used once. Okay, moving on. Next thing I want to show you is how to work out the inverse of a function. So if we have fx is equals to 3x minus 1, we're being asked to work out the inverse of that function. So the first thing you're going to do is you're going to change fx into y. So you're going to say y equals 3x minus 1. And I have the steps written down above. You're going to solve for x. So I'm going to get x by itself. So I'm going to bring the minus 1 over, and then I'm going to divide by 3. So x is equals to y over 3 plus 1 over 3. And then you're going to swap the x and y variables. So you get y is equals to x over 3 plus 1/3. So that is how you find the inverse, and I can change y then if I want into f of minus 1x, f inverse. And that's how you do inverse. Nice and easy, nothing too complicated. The other thing I want to mention to you is this Desmos graph I've done over on the right hand side to show you another important thing to know about inverse functions. And if we look at our original function, it's the green line. And if we look at my inverse function, it's the purple line. And what you should notice between it is I've put in this graph y equals to x. And there's a really important rule to do with inverse functions, is that the graph of an inverse function will be a reflection in the line y equals to x. So basically, if you're ever asked to sketch the graph of an inverse function, if you draw in your line y equals to x, it's literally a mirror image out the other side. So if we look at this exam question, again, I'm not going to go through all of it, but the last little bit here, we're being asked to sketch the graph. So I'm going to show you that really quickly. So for this question, we're being asked to state whether or not gx is injective. Now look, there's a few different ways you can do that, but another little side note I want to mention, if you're trying to prove injectivity, you can use something called the horizontal line test. Okay, now we would have used the vertical line test to prove that a function is a function, but we can also use the horizontal line test. So horizontal line test. So the horizontal line test is basically if you can draw a horizontal line and it's only going to cross the horizontal line once, you can say that it's injective. And that's basically what you needed to say. So you can say, yes, this is injective due to only crossing a horizontal line once. Now, the vertical line test, as just a little side note, is how you prove that a function is a function. And if it only touches the horizontal line once, then it's just a normal general function. Okay, and I'm going to skip down to the last part. It says find the inverse of your function. So again, if we just do this really quickly, we've got the square root of 4x minus 3. So again, what you're thinking about with this one is you want to get x by itself. So you need to get rid of the square root first of all. So you're going to square both sides. Then you're going to bring the 3 over. And then you're going to divide by 4. And then you go and change your signs, or your x and y. So you're going to get the inverse is equals to x squared over 4 plus 3 over 4. Now, obviously, you can keep them as one fraction as well if you want. And then the only other thing I want to show you on this one is just to show you where you can very quickly sketch your graph of your inverse. So again, you should have a ruler when you're doing this. But if you went with your ruler and you drew your x equals to y on that, it would be quite easy then to go and actually graph your inverse function, something like that. And again, I haven't done that properly because I don't have my x equals to y line drawn, but again, hopefully you can see the relationship there. You can very kind of easily, once you have your y equals to x line drawn, you can see the reflection of the other line. And the mark scheme has it done a lot better than me there. If I just zoom in there, you'll see it. So they've gone and sketched, they're drawn in your y equals to x line, and then you can see the where that meets it. Then you can obviously look at the relationship between the two. Okay. Okay, so I'm just conscious of the time. I want to keep going with to get on to a few other topics today as well. I'm going to talk to you a little bit about some differentiation stuff and some complex numbers stuff as well. Last one or two bits on functions then before we move on to complex numbers is just a composite function. So a composite function is basically when you put two functions kind of together to come up with a new function. And you know, you'll see it when it's written like this. You'll see it referred to as like f of gx, or this one f after g. You know, you'll hear it spoken in different ways, but basically you just need to remember that you always take the one on the inside first, work out the answer to that, and then use that input in your other function on the outside, which in this case would be f. So just a quick example. If we're given f of x is equals to x cubed and g of x is equals to x plus 2. So if you're being asked to work out f after gx or f of gx, basically what you do, just write it here, is you imagine that this is your new input. So I'm going to take g of x and I'm going to write in x plus 2, and then this now becomes your input into your f value. And f was x to be cubed, so cubed stays, and then x plus 2 goes in there. And then if you went and multiply that out 3 times, you get your quadratic there. Okay, guys, so that's all I'm going to talk to you about on functions and algebra. As I said to you, that's not absolutely everything in that chapter, but hopefully it's given you a good kind of summary of a lot of the important parts. I have all of this done out in videos for those two topics, so please do visit examrevision.ie. I'll show you in a little bit more detail later on today, but if you want to do any more study on those topics, do visit our website, and I do have notes done up on all of those as well. So, you know, as kind of a checklist, those notes can be really, really useful. Okay, so moving on then, I want to talk to you a bit about complex numbers. I thought complex numbers was another important one to look at because I suppose it's a topic that I would say students do ask me quite a lot of questions about when they're studying for their mocks and their leaving certs. And it's also a question that I think is quite doable. It's quite approachable once you've gone back over some of your key terminology and, you know, how things kind of work with regards to the different words that you might not be used to seeing. And once you've seen them, you're like, oh, actually that's fine, I understand that. So this is just, again, a checklist of your complex numbers chapter. I'm not going to go through every single thing today, but again, just a couple of the main points I will reference. So some of you may not have done complex numbers yet, okay, but I'm only planning to do about 10 minutes on complex numbers and then 10 or 15 minutes, and then I'm going to do the rest of today on differentiation. So if you haven't done complex numbers, this should still be relatively useful because I think you should be able to pick up a few helpful kind of things to do with it. So the first thing is just to remember that complex numbers are just another form of our number sets. So back in junior cert, we would have learned all about natural numbers, integers, etc., etc. You would have learned up until you've done complex numbers that all numbers possible were what we call our real numbers. But now we have these other things called complex numbers. And a complex number is basically made up of a real and an imaginary number together. And that gives us this complex number. And I suppose the origin of complex numbers is just that when we went to find the square root of negative numbers, we realised that we couldn't do it. So if we can't find the square root of a negative, what happens? Well, then this is where our imaginary numbers come into play. So what I thought would be useful for this part, because I don't want to spend loads and loads of time going through questions, is I've just picked a few exam questions that I'll kind of dip in and out of to kind of, you know, explain some of the terms and things like that. So this question I did take from the ordinary level paper, but again, I just thought this was a good one. Instead of me going on and on about the Argand diagram and the modulus and blah, 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 I'm just going to show you a question to recap it. So the Argand diagram, first of all, is made up of an x and a y axis, but instead of the x and y axis, we label it the real axis and the imaginary axis. So with a complex number, as I said, we have the first part is generally the real part, and then the second part is the imaginary part. So if you're being asked to plot Z1, that means we have to go -2 across your x and 3 up on your y. So that's going to be your first coordinate there for Z1. Z2 is -3, -2, so you're going to go -3 across and -2 down. That gives you Z2. And then Z3, they're saying, is Z1 minus Z2. Now, look, you'll never get a question like this really on the higher level paper, but it would be part of another question, or it could be part of another question. So we're simply just adding those together. So that's +3 plus 2i. So we end up getting, you always add the reals and the reals and the imaginaries and the imaginaries. So we're going to get 1 plus 5i. So if I go and graph that, then that's going to be 1 across and 5 up. So that's going to be Z3. Okay, so that's your Argand diagram. So the next thing then we want to look at here is where you're being asked to work out the modulus, okay? So this symbol here means the modulus of a number. And basically what the modulus is, it's the distance from the point 0, 0 up to your coordinate on your Argand diagram. So if I was working out the modulus of Z1, I'm basically working out this distance here, and that should be a straight line. If I'm working out the modulus of Z2, it's that one. And if I'm working out the modulus of Z3, it's that one. Okay, so look, I'm not going to go and do all of this again. The mark scheme will be here for you. But let's just say we're being asked to work out the modulus of Z1. What you're going to do is it's going to be the square root of the real number part squared. So that's going to be -2 squared plus the imaginary part squared, which is 3 squared, not cubed. So that's going to give you the square root of 4 plus 9, which gives you the square root of 13. So that's your modulus. Just be aware you don't put the I in there, you only put the coefficient into your modulus. Okay, and as I said, the mark scheme is there to show you the end of that question. And then the next bit I wanted to talk to you about, this was part C of that ordinary level question, is where we're being asked to work out Z4, which is Z1 over Z2. So Z1 again was -2 plus 3i, and Z2 is -3 minus 2i. So again, this is just another important recap that I thought I should mention, is that when we're trying to work with fractions in complex numbers, we need to use conjugates, okay? So we basically want to rationalize the denominator, which means we want to get rid of the complex number at the bottom part of this fraction. And this is definitely something you need to be able to do for the higher level. So basically what you're going to do is you're going to multiply the top and the bottom by the conjugate of your denominator. So this is your denominator, obviously the bottom bit. The conjugate of any complex number is where you change the sign of the imaginary part of your number. So it's going to be -3 plus 2i. and you do that to the top and the bottom, because if you multiply the same thing to the top and the bottom, that's just multiplying it by 1. You're not changing anything, but you will get rid of your denominator. So you're going to just go and treat this like double brackets. I'm not going to do it out now because we don't have time, but you multiply the top by the top, the bottom by the bottom. I'm just going to do the bottom bit because I just want to show you what's going to happen. So that's going to give you 9 minus 6i plus 6i. Now be careful of this. So I hadn't mentioned this so far. So this is going to give you minus 2i squared. Okay, because it's the minus and the plus, minus 4 I squared. So what you need to be careful of, if I go back here, they do tell you in your exam question, I squared is equals to minus 1. So if you ever get an I squared in a question, you need to remember, so the minus 6 and that's going to go, and then you're going to get 9 minus 4 bracket your minus 1. Okay, so, and then look on the top, let me just do it out now since I've started. So that's going to give me 6 minus 4i minus 9i plus 6i squared. So that's going to give me minus 13i and then that's going to give me plus 6 times minus 1 all over. It's going to give me 9 plus 4. That's going to give me minus 13i plus 0 basically. So it's going to be 0 minus all over 13. So that's going to divide in. So we're going to get 0 minus I as your answer. Okay, so that's your complex numbers. Next thing I want to talk to you about is your conjugate root theorem. So another thing that you need to be aware of on the course then is if, and again we're talking about roots here, so think about what we learned about earlier. So if you know a complex number z in the form a plus bi is a root of a polynomial where the coefficients are real numbers, so basically where you've got like real numbers like, 3z squared plus 5z plus 10 equals to 0, then straight away you know another one of the roots, and it's the conjugate of this one. Okay, so look, this will make more sense when we look at a question now. I'm just going to go straight ahead here to this exam question. So it says here that minus 4 plus 3i is one root of this equation where a, b and c are all real numbers. Now that's really, really important. The conjugate root theorem will only work if a, b and c are real numbers. Simply, this is from the higher level exam now, write the other root. So if you know your conjugate root theorem, you know that the conjugate of this, which is minus 4 minus 3i, is the other root. So you can answer that question literally straight away. So that's your conjugate root theorem. Just to go back a second then, the next thing I want to talk to you about is de Moivre's theorem. So if you go to page 20 of your formula tables, you will see de Moivre's theorem there. It's kind of in the middle of your page. And I suppose the first thing to be aware of with de Moivre's theorem is it's basically like a rule where if you have a complex number raised to the power of n, that you can basically take it that it comes in and it hits off or, which I'll explain in a second, and it goes onto the shoulder, but it comes in and multiplies by your angles. Now, this here on the right hand side, forgetting about the power of n for a second, this right hand side is a complex number that's in polar form. So before you go and use de Moivre's theorem, which I'm going to show you now in an exam question, you just need to make sure that you put it into that format first, and then you can go and apply de Moivre's theorem. So I'm going to talk you through a quick exam question now. So it says, use de Moivre's theorem to express 1 plus I raised to the 8 in its simplest form. Okay, so the first thing we're going to do is we're going to write this number 1 plus I. So we're going to forget about the power of 8 for a second. We're going to write that into your polar form. So you have to work out your modulus, which we already spoken about before. So that's your OR. So OR is equals to the square root of 1 squared plus 1 squared, because there's just a 1 there in front. So that's going to be root 2. So OR is equals to root 2. We then want to go and work out our argument, okay? So basically what you do is you go and draw yourself a little sketch of your argument diagram. So it's 1 plus I, okay? So it's going to be 1 across and 1 up. And we basically want to work out this angle here, okay? So basically think about it like a little right angle triangle, and it's 1 and 1. So you're going to say tan theta is equals to 1 over 1. So theta is equals to, so you're going to do tan inverse of tan inverse of 1, which gives you 45 degrees. Okay, so you can leave it in degrees, or if you wanted to change it to radians, you could divide it by 180. So that would give you pi over 4. Okay, so that's the first bit done, right? And then to put it into polar form, basically what you do is you take your or, so that's going to be root 2. So we're going to say root 2 bracket, and it's basically the inside bit of your De Moivre's theorem. That's why it's great to have that page 20 open, because it refreshes your memory. So it's cos theta plus I sine theta. So it's going to be cos 45 plus I sine 45. Okay, that's it written in polar form. Now I need to take all of that and apply De Moivre's theorem, which basically means I need to use that 8 and let it come down and hit off the relevant parts. So again, go to page 20. It's going to refresh your memory. So what happens is this root 2 is going to be raised to the power of 8, and that 8 is going to come in and hit off each of my angles. So it's going to be 45 multiplied by 8 plus I sine 45 multiplied by 8. Now, I'm keeping my calculator in degrees. If you have your calculator in radians, so just double check what you have up the top of your calculator. Obviously, it will depend. In this question, it didn't really matter which one I used, because I'm trying to obviously evaluate it at the end. So that's going to be root 2 raised to the power of 8, and that gives me an answer of 16. And then in my calculator, I'm going to do cos bracket 45 by 8, or obviously you can work that out beforehand, and that's giving me 1 plus I, and then I need to do sine 45 multiplied by 8, and that gives me 0. So that's obviously going to just go to 0. So that means it's going to end up giving me an answer of just 16. And that is your final answer using De Moivre's theorem. Okay, the next thing I want to talk to you about is, I'm not going to do this one out fully, but it's just to show you, this is part C of this question, again, higher level. So I spoke to you already about your conjugate root theorem, and we said if we know that one of them is a root, then the other one, the conjugate, will be a root. But that's only if the coefficients are real numbers. And this question threw a lot of students off, because you're looking at this, you're seeing, oh, they're telling me that's one of the roots, find its other root. But what you notice is that these do not have real coefficients, so you cannot use your conjugate root theorem. So the trick for this question, again, you can do it in lots of different ways, but what I always say to my students is, right, this is a root. So what you're going to do is you're going to change that into a factor. So remember, as a root, it's z equals 1 plus I. So to change it to a factor, you bring everything over to the left-hand side of your equation. So you're going to have z minus 1 minus I. So that's a factor. And if we go back to our algebra, when we're talking about how to work out other factors, we do division. So again, different teachers will teach this different ways, but I would do long division to work out the missing value there. So I probably actually multiplied this out here just to make it a little bit easier. So it's going to be z squared, sorry, it's going to be a minus, isn't it? Minus 2z plus I z plus 3 minus I. And you're going to go and do long division, exact same steps as we did before. So what you multiply z by to get z squared, it's going to be z, that's going to come down here. And you're going to go and work out everything, and you'll end up getting your next answer. Okay, I'm just conscious, guys, of time. I don't have time to go through that. But again, I do have it all screenshotted here for you, so you can see literally the exact steps that you're going to take to go through that. Okay, and then the last thing I want to talk to you about then in complex numbers for today, before we move on then for the last 20 minutes or so to talk about differentiation, is your the last bit of complex numbers. So basically it's where we're being given information about like a complex number, but we're basically being asked to work out the roots of a complex number. Okay, so again, it's something that is kind of would be considered, I suppose, one of the slightly more challenging parts of the course. But again, it's not too difficult once you've seen it done out. So we have v equals to 2 minus 2 root 3i, and we're being asked to write it in that form. And then we're being asked in the next part to go on and to work out the roots of that. Okay, so I'm going to just skip the first part because that's just writing it in your polar form, which we've gone through already. So you go and work out your OR, which is your square root of 2 squared plus minus 2 root 3 squared. And that's going to give you an answer of 4. And then you go and you work, actually I should show you this because I think this is important, just to work out your angle. So basically you're going to go and sketch this. So it's going to be 2 across and minus that down. So it's going to be, let's say here. So that's 2 minus 2 root 3i. And basically what you need to remember is, and I haven't mentioned this yet actually, but the angle that we're going to work out using this is going to be this angle here. Okay, now I always take it to be positive. So I'm saying this value here is a value. So it's going to be it's going to be 2 root 3. And this distance here was 2 across. You went 2 across and that's down. I'm taking these as positive angles. But we want to work out the angle to go from this point all the way around. Okay, so when we go and work out this angle here, so I'm going to work out tan of alpha, which is going to be the opposite over the adjacent. So when I go and work out that angle, let's do it here now. So it's going to be tan inverse of 2 root 3 all over 2. Obviously that's just going to be root 3. So that's going to give you 60 degrees. I'm just going to keep this in degrees for the moment because I'm not going into radians really in today's lesson. And I don't actually want that angle though. I want this angle that went all the way around, which is theta. So theta is obviously going to be 360 minus 60, which gives you 300 degrees. Okay, so again, to write this in polar form, which we went through in the last question, it's going to be 4 bracket cos 300 plus I sine 300. Okay, and that's your answer for the first part of that question. Okay, now as I said, you can obviously write that in radians as well if you wanted to, but you didn't have to. Probably should put my little degrees in there as well. Okay, so the next part of this question then is where we're being asked to then use your answer to part BI to find 2 possible values where w squared is equals to v. Okay, so basically what you need to do then is you need to say, right, that means I'm trying to work out the value of w, which means I need to get rid of that squared, which means basically what we're trying to do is we're trying to find v to the power of a half, like I'm square rooting both sides. So I need to go and apply that then to my question. So what you're going to do when you're finding the roots is you're going to go back and say, well, if I worked out what v is, so if I go back here for a second, we just worked out that v in polar form looks like this. Okay, so that's going to be really, really helpful to us for the next part of this question. So I'm just going to write that down there for a second. So v is equals to 4 bracket cos 300 plus I sine 300. So we're going to use this to help us. But what I need to remember is because I'm dealing with your roots, okay, we're dealing with like the fact that it's cyclical, okay, and we can get our answers in different sections of our graph. So what we need to do then is we need to actually add a slight extra bit on here, okay, and we need to say that in order to find our roots, we're going to say it's 4 bracket cos 300, but you need to add on plus 360n, okay. You might remember of doing that when you're basically trying to find out the different areas in your Argand diagram where your answer is going to lay, and then it's I sine 300 plus 360n. Okay, now what I need to do is I need to say, right, in order for me to get that answer, I need to take v and I need to raise it to the power of a half. And now I'm going to use de Moivre's theorem. So that half is going to come in like we did in de Moivre's, and it's going to give me 4 to the power of a half. but then it's going to come in here and it's going to divide everything, like it's going to multiply everything by a half. So that's going to give me cos 150 plus 180n plus I sine 150 plus 180n. Okay, so that's obviously going to give me 2 and all this stuff. And then all you need to remember to do then to finish off this question is we're trying to find the 2 roots because it was to the power of 2. So because it's 2 roots, what you need to remember is that there should be 2 values you're going to sub in. You're going to sub in n equals to 0. So you're basically going to go and sub 0 in there and in there. And you're going to sub in n equals to 1. And that's going to give you your 2 answers. Okay, so I'm not going to go and do that bit out. But basically, if I go on to the next slide, you'll see they've subbed in 0. And they get that and that. They multiply it by 2 then, because remember 2 is on the outside. And they sub in 1. And again, they get their 2 final answers there. Okay, so again, guys, I know I've gone through that really quickly, but I do have full videos done out on complex numbers on ExamRevision.ie, so do have a look at that. Okay, so we've got about 20 minutes left. So what I want to do then, just to finish off today, is to go through some information on differentiation. Again, differentiation is so important for the Leaving Cert course. It comes up so much, and it's one of those things that, like, yeah, it comes up in lots of different areas, particularly when we're talking about like functions and turning points and stuff like that. So to start off with then, I'm going to talk to you very quickly about first principles, and then I'm going to talk to you about a few of the other kind of formulae that we can use to help us with differentiation. So first principles, you basically need to know this off by heart. Okay, so you need to remember that when we're differentiating, basically what happens is when we differentiate, we're finding the slope of the tangent to a curve. So in very simple terms, that means that if we are trying to find the slope of a curve, we know it changes all the time. So when we're finding the slope of a straight line, it's just one answer. But when we're finding the slope of a curve, you've got increase, you've got decrease, you've got turning points, etc., etc. So differentiation allows us to basically come up with a formula that represents the tangent at a particular point, and then we can sub in that value and actually work out the exact slope at that one time. So this is what first principles allows us to do. So I suppose, look, the main tip I would give you when you're doing first principles is to break it up into different steps. So you're going to start off by saying, okay, this is what we're being given. It's fx and it's equals to 2x plus 4 all to be squared. So what I would probably do to start off with is I'd actually multiply this out. So it's just done, and I kind of have them as individual terms then. So when I multiply out that double bracket, that's going to give me 4x squared plus 16x plus 16. Step 1. Step 2. And again, if you go back here, I'm not going to write it out now because I just have it on this slide. This needs to be in your head, the different steps. So I'm going to start off by doing this bit here. So down the left-hand side of my page then, I'm going to write f bracket x plus h. And here then, wherever I see x, I'm going to put x plus h in. So it's going to be 4 bracket x plus h squared plus 16 bracket x plus h plus 16. That's going to give me 4 bracket x squared plus 2hx plus h squared plus 16 x plus 16h plus 16. And I always kind of tidy up before I go and do anything else. So that's going to give me 4x squared plus 8hx plus 4h squared plus 16x plus 16h plus 16. Okay, that's step 1. Step 2 is I'm going to go to the next step, which is where I minus fx away. Okay, so I'm going to do my next stage, which is fx plus h minus fx. Now I'm going to be a little bit lazy here. I'm not going to rewrite this all out. I'm just going to do the next bit where I minus fx. So I'm minusing this away. Be careful, the minus obviously hits off everything. So it's going to be minus 4x squared minus 16x minus 16. So that means that's going to cancel, that's going to go, or not cancel, goes to 0, and that's going to go to 0. So that means I'm left with 8hx plus 4h squared plus 16h. Okay, now I'm going to go back again. next step is I divide everything by h. So fx plus h minus fx all over h. So I'm going to take each of those and I'm going to divide them by h. So h is going to go in there once, going to go in there once, going to go in there once. So I'm going to be left with 8x plus 4h plus 16. And then my final step, again, if I go back, we have the limit h goes to 0. So we're going to send h goes to 0. So the limit h goes to 0. I'm being really lazy now. I'm not going to write that out again. So h goes to 0. So that's going to become 8x plus 4 bracket 0 plus 16. So it means my final answer is 8x plus 16. Okay, and that is your answer. That is differentiation by first principles. Now, if we did that the other way, if we went and just differentiated this by rule, I'm going to do this one here. We can double check our answer. So you should know to differentiate a term, you take the indice on its shoulder and you bring it down and you multiply if there's anything in front. So that becomes 8x, and you drop the power by 1. So it just becomes to the power of 1. And then I'm going to do the next one. So 1 comes down and hits off 16, so it becomes 16. X goes to x to the power of 0, which turns to 1, and then 16 goes to 0. So that's my answer, and you can see that was the same as I got for differentiation by first principles. Okay. Couple of other short things I just want to show you guys. I know we're nearly done for today, is our chain rule. So our chain rule, so again, for anyone I suppose who is starting to revise differentiation, I suppose it's important to remember that some of this stuff is in your formula tables. So if you go to page 25 in your formula tables, you'll see that there's a lot of this stuff written out. It can be kind of confusing in the formula tables, but I do think it's really important to have it open in front of you, okay? So you'll see in on page 25, the bottom right hand corner, they have a thing called the chain rule. Now, I like to just teach this one kind of using the quick way rather than the kind of du and dv and stuff like that. So the rule is for the chain rule, it's basically when we have something raised to a power and there's more than one thing inside the bracket. You can use your chain rule. We also use it in trigonometry, which I'm going to show you now in a second. So your trick is you pretend that the bracket, the bracket is just like an x for a minute, and just do what you would normally do. So imagine it's like 2x to the power of 5. So you'd take the 5 and you'd multiply it by the 2. So you'd get your 10. So you can see it there, 5 by 2. And then you reduce the power by 1, so you get the 4, and you just write that bracket down as normal, but you don't think about it. And then what you do is you multiply it by the bracket differentiated. So then you take 1 minus x and you differentiate this, and you end up getting dy dx is equals to minus 1. That's where that minus 1 came from. So then you get 10 multiplied by minus 1, which gives you minus 10, and you've got 1 minus x raised to the 4. So that's just the quick way of doing the chain rule. The next one then you need to know is your product rule. So your product rule is where you have two things that are multiplying by each other. Okay, now again, this example I have here is like not necessarily the easiest example to look at, but it's a good one. So basically you've got this bracket multiplied by this bracket and you're being asked to work out dy dx. So this is your product rule. So again, if you go to page 25, it's the one on the top of your page. So the way that you approach the product rule is you label your first thing that's multiplying as u, and you label your second one as v. So I've done this over here in the right hand corner, and you go and differentiate each of them individually. So when you differentiate u, you write it as du dx. So you're differentiating u with respect to x, and you get your 2 comes down, you get 2x. You then go and differentiate v, so it's dv dx, and you get 4. Then you go to your lovely formula and you write this down and you say, you just fill it in. So u was x squared minus 3, dv dx was 4, v is obviously 4x plus 1, and du dx was 2x. Pop them all in, multiply them out. We should really have dy dx written the whole way down here. So dy dx is equals to that. Okay, so that's your product rule. And sometimes students say to me, how am I supposed to know when to use the product rule? You use the product rule when two things are multiplying by each other. And then you use the quotient rule, which is here. That is like divide. So it's when two things are dividing by each other. So if you see a fraction in a differentiation question, you should use your quotient rule. And again, that's also on page 25. It's in the middle of the page. So it's basically the same steps as the product rule. So you take the thing on the top and you label it as u, and you take the thing on the bottom and you label it as v. You then go and differentiate both of them, so du dx and dv dx. And then, so just explain where this answer came from. So basically you did 3 bracket x squared plus 4 raised to the 2, and then you multiply that by the bracket differentiated, which gives you 2x. So that's where that 6x comes from. And then you just go and fill out your lovely formula. It's all done out for you there, and you get your answer. So that's your quotient rule. The next one I want to talk to you about, this one probably causes the most amount of issues, is differentiating your trig functions. So if you look to page 25 on the left hand side, you'll see that it gives you some really helpful things there. It tells you what cos, sine and tan x is when you differentiate them. So if we take a simple enough example to start off with, okay, cos 4x. So basically what you need to do when you're differentiating a trig function is you need to go to your formula table straight away and figure out what cos is when you differentiate it. And you'll see that it's minus sine. So what you do is you write down your minus sign and whatever is in the bracket. So this is basically like the chain rule. So you take your trig function, you differentiate it, you leave whatever's in the bracket, you forget about it, you just write it down, but then you multiply it by the bracket differentiated. So 4x differentiated is 4, and that's where we get this as our final answer. Now the next example I've shown you is a more challenging one because we basically have a few different things at play here. We have to differentiate the cos 3x, but then we also have to take care of the power of 4. So there's kind of 3 steps here. So in this one, there was 2 steps. It was differentiate the trig function and then differentiate the bracket. In this step, you differentiate the power, then you do the trig function, and then you do the bracket. So I'm starting off with this power of 4. Now imagine it's the same as it being up like that. Okay, we just write it differently for trig functions. So the 4 is going to come down. And remember, we're just dealing with the power at the moment. Everything else stays the exact same. So the 4 comes down. The cos stays there, which does confuse people because in this example, the cos went because we didn't have to differentiate the power as well. So the cos stays there and the 4 becomes a 3. The bracket stays the same. So that's like the first little bit, step 1. Step 2 is we differentiate the trig function. So we do what we did up here. So forgetting about the 3, remember on the shoulder, we've done that. So you differentiate cos, which becomes minus sine. You write down the bracket. And then step 3 is you differentiate that little bracket, which was 3. And that's where your answer comes from. Okay, so this question then is a quick differentiation question. So it says let fx equals to 2x over x plus 2. Find the coordinates of the points at which the slope of the tangent to the curve is a quarter. So I really like this question actually when it came up because it made you kind of think about what differentiation is. So just remember, differentiation is where we find the slope of a tangent to a curve. Okay, so again, we're basically working out the slope of a curve. And they're basically saying to you, well, I'm giving you the answer. The slope of the curve is a quarter, but I want you to tell me what the coordinates were for that point. So what we need to do to start off with is we need to go and we need to differentiate, because when we differentiate, that gives us the slope to the tangent of the curve. So we need to work out f dash x. So this is a fraction, which means you need to remember that we need to use our quotient rule. Okay, so you're going to start off by going to page 25 and looking up that they're telling you y equals u over v. So I'm going to say u is equals to the top of my fraction and v is equals to the bottom of my fraction. I'm then going to go and differentiate. So du dx is equals to 2 and then dv dx is equals to 1. I then go and I write my formula down from page 25 and it's telling me that dy dx is equals to v du dx minus u dv dx all over v squared. So that's going to give me, so I'm just filling everything in, so it's v, so it's x plus 2 multiplied by du dx, which is 2, minus u, which is 2x, multiplied by dv dx. So I always like to circle them because you basically should circle them all once, and then it's over your bottom squared, basically v squared. So it's going to be x plus 2 squared. Okay. And then when you go and multiply that all out, I'm just going to do this across here. So that's 2x plus 4 minus 2x all over x plus 2 to be squared. They're going to cancel. So you're basically just left with, or they go to 0, you're left with 4 over x plus 2 squared. Now again, I really want you to think about this. This is dy dx. So that means that this is the slope of the tangent. So if I subbed in any value of x, that will give me the slope at a particular point. But they're kind of asking me it like in reverse. They're giving me the answer for the slope at that particular point, and they want me to work out the x and the y value. So all you're going to do is you're going to say, right, that's my equation. That's my answer. And you're going to do a bit of algebra. I'm not going to do that out now, but you're going to like multiply across by the x plus 2 squared and by the 4, and you get your two answers, sub it in, and you get your y values as well. Again, all that is done out. I have the solution here for you as well. Right, very last thing I want to talk to you about before we finish up then is turning points. So with differentiation, one of the main ways it comes up on the Leaving Cert is when we're talking about max and min problems, when I'm talking about turning points, when we're talking about where the slope is 0. So the most important thing you need to remember is if you're asked to work out a turning point in your exam, you need to remember that it's dy dx is equals to 0 because it's where the slope of your graph is 0. That's the first thing you have to learn off by heart. So turning points is where the slope is 0. So you go and work out dy dx. So in this really quick example, you can see they have an equation, they find dy dx, they let it equals to 0, and that gives them the coordinates of the 2 points at which their graph has no slope. So therefore that's where it's got a turning point. But then the next bit of a question that you might need to be able to do is they may ask you to determine the nature of the turning points. So is it a maximum point or is it a minimum point? So what you need to do then is you've worked out your 2 turning points, but you then, and it's done nicely down the bottom of this PowerPoint, is you then go and you work out the second derivative. Now all that means is you just differentiate the thing again, okay? And you sub in your x value into that second derivative, and if the answer is less than 0, it's going to be a maximum point. And it's all written here. If it says the rate of change of slope is negative, it's going to be a maximum point. And if it's a positive, so if it's bigger than 0, it's going to be a minimum. Now, that's kind of the counterintuitive way of thinking about it, but it's because it's going from like a positive to a negative and a negative to a positive. But you need to learn that off by heart, okay? So again, if we look at this quick example, so they differentiated it once, they differentiated it twice, and they found that this was the second derivative, and then they had the x coordinates, so they subbed it in, and they were able to see that for when they subbed in the -1, they got -12, which means that that's a maximum. Remember, it's kind of the opposite to what you would think. And when they subbed in 3, they got 12, which is positive, therefore it's a minimum point, okay? And then the very, very last thing I want to talk to you about before I give you a discount code for the website and talk to you about when our next revision is I'm actually not going to have time to do this one now, is just rates of change, okay? So this is definitely a question that students do ask me quite a lot about as well. So I'm going to do this one really, really quickly because I think this is a great one to look at. So a rates of change question, here are some tips for it. So as soon as you talk about a rate of change, we're talking about time. So you're going to be talking about differentiating with respect to time. So it says air is pumped into a spherical exercise ball at a rate of 250 centimeters cubed per second. So my trick with this one to start off with, if you ever have a rate of change question, is you want to think about the fact that it's the air in the ball. So it's the volume of the ball is changing at a rate of that, which means it's in respect to time. So the first thing you're going to do in a question like this is you're going to say dv dt is equals to 250. Okay, that's step 1. You're obviously going to read the rest of the question. They're saying find the rate at which the radius is increasing when the ball is 20 centimeters. Okay, they're asking you to work out the rate again. So they're asking you to work out dt also, but this time they're asking you to work out the radius is increasing. So we're finding, they want us to work out d or dt. Now, if you write down those two things, this question becomes a lot more approachable. But that's the thing I think students find difficult in rates of change questions. It's kind of like, where do I start? So that's your starting point. Then what I say is try and find a formula that's going to link the two together. So I'm thinking about the volume of a sphere here. Okay, so I'm going to write down V equals, and I'm going to go to my formula tables, and I'm going to write down the formula for a sphere, which is 4 over 3 pi r cubed. I'm then going to differentiate this. So I'm differentiating V with respect to what's the unknown over here. It's r. So I'm working out dv dr. So the 3 is going to come down. That's going to give me 4 pi r squared. Now what you're going to do is come back to this, and you're going to split it up. So the dr goes on the top. Now, I'm not obviously going into any of the explanation of why we do this. I don't have time, so apologies, but I'm just trying to give you the mechanics. So dr goes on the top of that one, dt goes on the top of that one, because I don't have dr dt. And I'm going to see, again, I've said V kind of puts this all together. So let's see, am I right? So do I have dr dv? Well, I don't exactly have it, but I do have this, which means if I flip it upside down, it's the same. So that's going to become 1 over 4 pi r squared. And I'm going to multiply that by dv dt, which I do have, which is 250. And all I need to do to finish off this question then is going to be 250 over 4 pi. And remember, I know what r is. It's 20. They've told me the radius is 20 squared. Pop that into your calculator and you get your final answer. Okay. So guys, we're just out of time there, so thank you so much for tuning in today. A couple of just quick things I want to mention. Anyone who has been watching our YouTube live today, you can use the discount code MATHS20, and that's going to give you obviously 20% off our website if you are interested in buying maths or any other subject on our platform. The other thing is just a reminder that on Wednesday at the same time, 1 o'clock, I'm going to be doing a recap of paper 2, and again I'll be picking some kind of key areas from it. Also, just to make sure if any of you are interested to follow us on social media, and we do kind of update you on all the different things that we have going on as well. And the other thing then I just want to show you really quickly is our website. So for anyone who hasn't seen our website before, just to give you, I suppose, a quick overview of it for anyone that's interested. So on our website, when you sign up, you can sign up as a free user and you'll be given access to one topic within each of our subjects. So just to show you as well, we have Leavenscert Business, Chemistry, Economics, English, Geography, German, Irish, Maths, and there is more to follow in the next couple of months. So in each of our subject folders, then you'll see I have the higher level and ordinary level course done. Let's say today you obviously learned a bit about complex numbers, but you want to do a little bit more. You can click into our complex numbers folder there, and you can see I have the course done up in lots of different videos. So let's say polar form you're a bit still confused on. There you go, you've got your video, a bit more into Moivre's theorem, etc, etc. You can also click into each of your folders and you'll see that we have our notes done up. So that's just another way of, I suppose, having a checklist of what you need to know in each of your chapters. And the way I've tried to do the notes is I've tried to link it to the videos. So if you're looking at something and you're thinking, I'm not really sure, of that, seeing it out as a written form doesn't always help. Sometimes you need to see it done as a video. So I do tell you, watch this video for more information on it. So there are your notes. And then we also have our exam builder. So that's also a really handy way, particularly for, I think, Leavenscert math students. Out of all subjects, really, it's so important to have. So if you click into our exam builder, I suppose one really handy thing is, obviously, look, we've got the course split up, but you can also, so let's say I go into higher level and I go into, let's say, complex numbers again. You can literally just look at the question, and then if you just literally click on the page, it will give you the mark scheme straight away. So it's just a really quick and easy way of building on your revision. You can obviously make them into an exam. You can add them in by just pressing the plus down the bottom, and it will build you an exam that you can obviously print out as well. And that all comes with our subscriptions to the website. The final thing is just to remind you, as I said, we've got Maths Paper 2 coming up on Wednesday. If there is questions, please feel free to send them in to us. I'm conscious, obviously, of the time, so I am going to try and answer just a couple of quick ones here now, but obviously people may want to finish up, and that's fine. I'm sure everyone's tired after a busy day. But yeah, I will definitely do my best to continue answering those questions as we're going along, and I'll do them through our Instagram story. But just a reminder that we do have other subjects as well on the website, or on our YouTube, where we're going to be doing our masterclasses. So there is an English one this Saturday, and there is other ones coming up as well. So just keep an eye out on Instagram, and we should be able to kind of figure it out from there as to what the different things that are coming up as well. So just looking at a few of your questions, will the YouTube live be saved? Yeah, we will make sure to save it. Can we get the notes afterwards? Yeah, 100%. If you want to make sure you filled out your information in the comment section below, or the description below, I can send you on the notes, no problem at all. And I think that's actually it. I don't think we have any other questions there, which is great. So if there is anything else, guys, feel free to pop them in now. I will check them out afterwards. And yeah, it'd be great, guys, if you could like and subscribe to the YouTube channel, and obviously give us reviews or whatever if you found today useful. And I will finish up there now, guys. Thanks a million for tuning in, and if you would like to join us again, we'll be meeting at 1 o'clock on Wednesday on YouTube. Thanks, Mel.